this video, we will see the bubble sort technique. Bubble sort is a very simple method and with a elementary sorting technique that can be uh, studied in the elementary stages. In general, by knowingly or unknowingly also, we will perform this bubble sort algorithm for general sorting purpose. So bubble sort is a very simple method that sorts the array elements by repeatedly moving the largest element to the highest index of position of the array in case of arranging the elements in the ascending order. In bubble sort, the name is telling you that like how whenever you turn the water bottle up and down, upside down, how the bubbles will come. So these bubbles will shift the positions. Okay, these bubbles will shift the positions from one position to the previous to the next to the next, like that. So in the same way, the highest element will be bubbled, means will be shifting the places from the normal place where it is originally is having to the highest index position. So the bubble sort in the bubble sort, consecutive adjacent pairs of elements in an array are compared with each other. If the element at the lowest index is greater than the element at the higher index, the two elements are interchanged so that the smaller element is placed before the bigger one. This process is continued till the list of unsorted elements are exhausted in the list or in the array. For example, to discuss the bubble sort, let us consider the following example: 30, 52, 29, 87, 63, 27, 18, 54. First, compare 30 with 52. So 30 and 52 is in the correct place. Now compare 52 with 29. Look at here how the bubbling is happening. First 30 and 52 will be compared. When it is in the place, then next 52 and 29 will be compared. Since these two are not in the place, so these two will be swapped. 29 will be swapped with 52 and 52 will be placed in the 29 position. Now 52, once it is done like this, now 30, 29, 52. Now what will happen is, now 52, the position came to the 52. Now 52 is compared with 87. It is in the correct place only. Now the position will be incremented. Now 87 is compared with the 63. So whenever it is compared with the 63, 87 is greater than 63. Hence, it will be placed in the normal position, 63 and 87. Now the position will be incremented. It will come to the position at the 87. Now 87 and 27 is compared. So since 87 is greater than 27, 27 will be 27 and 87 will be swapped. So 27, 87. Now the position is incremented, 87 here. Now 87 is compared with 19. So again 19, 87. The swapping will take place. Now the position is incremented. 87 and 54 are compared. 87 is greater than 54. So swapping takes place. So this entire procedure till the end of the unsorted list is said to be one pass. Like that again in the second pass the same operation will happen, and in the third pass also the same operation will happen. Whenever we find the all the elements are in sorted order, then the flag will be set to 1, and when the flag is set to true or 1, then it comes to know that the elements are in sorted order. So observe, after the end of the first phase, the largest element is placed at the highest index of array. All other elements are still unsorted. So in the past two, what will happen again? 29 is compared with 30, and 30 is compared with 52, 52 is compared with 63, 63 is compared with 27. Now 27, 63 swapping takes place. Now 63 is compared with 19, swapping takes place, 1963. Next is 63 is compared with 54. So 63 is greater than 54, swapping takes place. Now 54, 63, and 63 and 87 is in correct place. Like that in the past three remaining other nodes. So like that it will go for how many number of elements are there, that many passes almost it will go through. So that is the reason in an algorithmic way, we can say bubble sort of a comma n is repeat step 2 for I is equal to 0 to n minus 1. Repeat for j is equal to 0 to n minus 1. If a of j is greater than a of j plus 1, then swap these two elements. Otherwise, just you continue the loop. So here you look at repeat step 2 for I is equal to 0 to n minus 1, and here j is equal to 0 to n minus 1. Means here outer loop will run for n times and inner loop will also run for n times. So thereby what will happen? N into n, which is called n square. Then it will become n square. So the time complexity of the bubble sort is order of n square. So this is what the bubble sort is. Now we'll go for implementation of this particular algorithm. I am naming this file as linear sorting. So in which the main aim of this is programs. Program is implementation of linear sorting methods. First one is this bubble sort. Second one is insertion sort. Third one is selection sort. So these are the three sorting techniques were implemented in this program. First one is void bubble sort of int a, so array, and int the number of elements in the particular array. So further we need to display the array also. So for this I am taking the help of the quicksort algorithm, so in which already I have defined the displaying function. So this display function straight away I am going to use here to save time. So displaying function, in this I am going to use the program for this. Next, bubble sort. Now we will go for implementation of the bubble sort. Then we will go for checking whether this code will sort the elements via using bubble sort. So I am going to define the bubble sort, insertion sort, and selection sort in the same file. So display function I have already copied and pasted from the quicksort, and bubble sort is this one. And we just now I have explained about the algorithm. So this is the bubble sort algorithm. Here we need to repeat the for loop from the I to I is equal to 0 to n minus 1 and j is equal to 0 to n minus 1. Then a of j is less than a of j minus j plus 1. Then we need to go for swapping. So the same operations will perform here, and we'll code the same thing here, and we'll see the result. Now here for int I is equal to 0, I less than n, I plus plus, and for j is equal to 0, j less than n, j plus plus. If a of I is, so what is the condition? If a of I, so look at the algorithm. If a of I, a of j is greater than a of j plus 1, then we need to perform the swapping. So a of j is greater than a of j plus 1, then perform swapping. So how will perform swapping? Int temp is equal to a of j, a of j is equal to a of j plus 1, and a of j plus 1 is equal to a of j. So this is the swapping what we'll do. Once it is done, then the array will be in the sorted order. So this is what the bubble sort is. Now we'll take the help of quicksort. We'll copy the elements from that to save time. Here previously. Actually, in the searching we have used many elements. Searching. Well, we have used many elements here. So let me go for copy paste. So here and display of a comma n or a comma size. Okay. Then perform bubble sort of a comma size minus. Let us say size only because it is I less than n we have traversed. Then after sorting, that will print the elements. Now we'll run the code and we'll see. Here 3333 some error was happening. Okay, here it is. Swapping should be temp. So temp should be swapped. So int temp is equal to AFJ, AFJ is equal to AFJ plus 1, AFJ plus 1 is equal to temp. Now we'll run the code and we'll see. Well, 3, 4, 5, 8, 9. So this is in the sorted order. So now the bubble sorter is giving us the swapping technique. That means it is based upon the swapping of the elements, but however, it is taking for I is equal to 0 to I less than n and j is equal to 0 to j less than n. The complexity will become the order of n square. This is the end of the bubble sort.